Um, so Carson put together much of this, and we'll give the majority of the slides with me jumping in a few places. Can everyone see that okay? All right, Carson, just let me know as you want me to go through slides.
Okay, perfect. Yeah, so primary elements for what we have for the system right now is physical implementation, but no direct intervention with the pressurization or filtration. It merely just is an algorithm and sending data. Yeah, monitor and reacting to air pollution events, and then engaging with members of the household, interacting with the system. So an overview. So it monitors outdoor pollution, looking for indications of deteriorating conditions. And when it sees a scenario where we anticipate poor air quality, it'll send a signal to the intervention node, which would begin pressurizing the home or running an air filter. And on the right is a diagram of a schematic of the current system. So we'd have a central hub, which has its own dedicated network, and is receiving data from nodes all around the house. And then that is making a decision, sending a signal to the intervention node, which would control the pressurization or filtration.
Now, just one quick thing to add there. So what Carson is going to be talking about primarily is the sensor node, the central hub, the anticipatory stuff. The intervention node is what Jordan is doing, that I think we'll have an update on here soon. So that's going on, just not part of what Carson is talking about today.
So the distributed system, and the control and interventions are across different physical locations. Yes, if you want to expand on this, Dr. Ron.
Sure. So what we're talking about here is we have some distinct different areas in the home, around the home, that we have to work with. So we have the central hub where the people are, which is physically separated where we're monitoring air quality conditions, which is physically separated from where we're doing our intervention. And so a lot of the nuance of what Carson has been working on moving forward the last couple of months is how do we do each of those well when each of them need to work quasi-independently. Because we did not want to limit ourselves to running data lines between each of these nodes throughout the house, we are using our own data network. So he'll talk more about that. But essentially, we're setting up our own Wi-Fi within the home so that all of our components can work independently without being reliant on any existing data infrastructure in the homes.
Yes, so over the network, we can use a messaging protocol called MQTT. It's extremely lightweight, so not computationally heavy on the Raspberry Pis, which is exactly what we need. The central hub, the main Raspberry Pi, acts as the broker, and kind of distributes and receives messages. So yeah, and you can send and receive messages both ways. Yeah.
So this is the platform about how we talk back and forth. So when Carson is talking about messages, although this could be like text messages, it's how we're sending all of our commands and receiving all of our sensor data back.
Yes, so the main Raspberry Pi can broadcast its own local Wi-Fi network, which the smaller sensors, or the smaller Raspberry Pis, which are connected to the sensors, automatically connect to upon activation or just being plugged in. The range for the network outdoor is like max 60 to 70 yards. And we've tested it indoors. It can pass through multiple walls in a home. But yeah, like we said, the local network is needed, so we don't have to rely on the homeowner's network and any interference with that. And yeah, any device is able to join the network, and yeah, you can go to the next slide.
Yeah, one thing to clarify that any device that we provide the credentials for.
Right.
So we're gonna be leveraging that, so we're not making this open to the home users. But we can come in with additional devices added onto the network with very minimal burden, which we'll talk about more here in a little bit.
Yes, so each node in the system has a smaller Raspberry Pi, an SPS 30 sensor for measuring PM 2.5 levels, and then BME 280 sensor, which records humidity and temperature. This data will be collected every minute and sent to the central hub. And then this data is then stored on a database in the central hub. Yeah, and these nodes, we can create as many as we want for any specific house. So yeah.
In productization of this, we would not be going with Raspberry Pi, but the same coding would work on other platforms. We're going with this hardware, although it's more expensive, for the ease of ramping this study up. Just the expediency and all of the different options, because there's likely going to be need throughout the study, or we're guessing, to add additional sensors or measurements or requests on. So we way overspec the hardware to leave that door open for us in the future.
So can you, maybe this is coming, but can you say something about what you see as the risks of, what could cause this to fail? I think you've been thinking a lot about that, and so just so we all know, maybe you can share something about that.
Yeah, there's a de-risking slide and error handling and stuff like that here in a little bit. Yeah, great question.
Yeah, that'll be covered in a little bit. Yeah, so the central hub is made up of Raspberry Pi 4B with the SPS 30 sensor, BME 280 sensor, the display screen, which is shown on the bottom right, and then a protective case, which, yeah, it's a fairly robust case, and yeah. Okay, so for extraction data during the study, we won't have to go into the homes at all. We can actually drive right up to the house with a laptop or a Raspberry Pi that is set up for this. You can connect right to the network and then run Python code, which I've created, and it'll automatically, so it'll send a signal to the central hub, which will send all the data from the database over MQTT to the computer, which will then store it in a new database on that laptop or Raspberry Pi.
We also have the option, if we decide that we're going to go this way, to have this data connect to the home network on top of what Carsen is doing, if we want to gather data in real time. But in the event that homes are not going to have internet, or we elect to not limit ourselves to that, we'll be able to go in and, as Carsen said, not even get into the home, but just get in close proximity and pull all of our data. So I imagine in implementation, we might end up having kind of a roving team that goes around from time to time, gets close to a home, pulls our data, and keeps driving without needing to schedule something with the homeowners. Now we need to be careful that we don't come across as like the creepy van driving through the neighborhood, scoping out people's homes, but we'll be able to access the data without going inside if need be.
Okay, yeah, so this is part of the anticipatory control. And this is how we would decide whether or not we want to pressurize or filtrate before indoor conditions have gone bad. And currently this algorithm is under development, but part of it is how the cost consequences of it. So if someone would like to run the system less to save money, or developing that algorithm, and then if they would want to be more protection but have higher energy costs, it would be a different and intervene more. And I think some stuff we're trying to find out is what would be an adverse air quality event. And then also some obviously different places are going to have different baseline air pollution. So we can't just set it at a certain level because it would run all the time. So we need to set a baseline for specific locations and then base the intervention on the air quality compared to that baseline.
So I think this is one of our big questions that we'll need to spend some good time as a team thinking about as we kind of hone in on our final locations for this first round of testing, is setting our thresholds appropriately that we feel like it's going to run, right? And we're going to have enough events to have the technology run, to gain feedback from users without it becoming burdensome. So balancing the kind of false positive, false negative of running when it's not needed, not running while it is needed is going to be a really delicate line for us to hit on. And I think one that would be a really good one for us to have a focused discussion on at some point about what is our kind of philosophical approach for the pilot study for when we run. We have a lot of control, and I think what Carsen has done so far, it'd be pretty easy for us to tune to different thresholds, but it's just, the two of us making a judgment call right now, which is probably a inappropriately small group to be setting those thresholds right now.
Can I
Yes.
ask a question?
Yes.
Like, you could imagine somebody deciding to run all the time, right?
What was that? Sorry.
Like, you could imagine somebody deciding it to run all the time. Or
Yeah.
deciding that they wanted it to run all the time. Like, I know that you said this is just for adverse events, but I really want to protect my child who has asthma.
Yeah, that could be something to add. And I think that's what we want. We're curious about is adding a user, different modes. And then also has to do with the for a user to intervene if maybe they want to shut off the system when it turns on and off. But yeah, that is something that we would be interested in implementing.
So I'm sure we'll have longer conversations with with the communications team and the human interface facing team, but right sizing what features we provide in the dashboard seemed so mundanely simple when we started before, and the rabbit hole of possibilities we have come up with is shocking. So I think there's, this is overly bold statement, but I think there's a few things we wouldn't be able to build in terms of controls and options and things like that. But determining how many different options we want to provide while still collecting the data that the team needs for the participant focused thing is, I think we're quickly coming up on that. And I know members of the team have been thinking about that more than us, but I think this is another area that doing like a working session, at a whiteboard where we sketch out some different ideas and options that we want to get tested sooner rather than later be very helpful from Carsen and I's standpoint. We've opened the Pandora's box of options, and the beast inside is getting a little scary to me. So
So
Yeah.
when do you think you need that conversation to happen, Christian?
Oh, like let me answer that in two ways. I think we're ready to have it whenever. I think the longer we wait to have it, the more likely that Carson and I are going to say no. So I think we are to a point, and we'll talk more. We have example hardware that Carson's ready to kind of start distributing to people, which was like a kind of a big milestone before we moved on to some other pieces. Those are extremely close to being ready. I have a pile of these monitors sitting in my office right now. So I think now is the time to at least start those conversations, and I'm sure it'll be a iterative process.
Yeah, so currently we are developing the algorithm to detect poor air quality events. Right now we have it so it'll take a baseline reading every morning, very early, to where there's no you know, before any traffic or anything. And then it is using that baseline level to decide if there is going to be a poor air quality event, and if we should intervene and send a signal to the filtration or pressurization. Currently, so we just ran a 2-week test on this algorithm, and you can see in the bottom left is a graph. The blue is the PM 2.5 levels, and then.
So if you wait for just a minute, Carson, I think it's bigger on the next slide.
Oh, okay. Oh, yeah. Yeah. So the top left, blue's PM 2.5 levels, and then all the red dots are when the intervention would have occurred. And then the green dashed line is that baseline level. Currently, it did detect most peaks, but you can see there is an issue around the 9th to the 11th, where that peak, the relay is not on because that baseline level is too high. So I pulled that and changed the algorithm to not have a baseline level that high, because when you have those peaks for so long, it'll set a baseline level closer to that top of the peak, which is not what we want. So I've changed it to exclude events like that, so the baseline level is not high. And then yes.
So it's a rising edge type algorithm. So we did some work about like how early would we need to start looking. And in reality, for the way we're doing our intervention, all we need is to see that an event is getting close. So we were trying to do some more predictive things, and how early, really the rising edge seems pretty reasonable. Now we have some offset periods to try and make sure that it's not just a blip of noise. You know, it has to rise and stay up for a certain period of time, but it's a pretty basic system right now, which seems to have worked better than, I'd say, the more complicated pieces we started to put in. Allison, I saw your message in the chat. What we mean by baseline here is what we're considering like typical for that day. So the way the algorithm is set up right now, it does intervention when we see an event different than normal. So in an area where air pollution is always high, as it's set up right now, the control system would not always be running. It would be looking for a really bad event on top of an already bad baseline. In really clean environments, it might be pretty low overall concentrations, but a meaningful difference from typical. Hopefully that helps clarify. We can chat more about it here.
Yeah, thanks, Christian. I'll let you keep going. I don't think
Yeah.
it helps to know. Thanks.
So as Carson was saying, when we have these really high extended periods, the way we have the baselining being done right now, things would actually shut off, right? It's been bad for a long time. We don't keep running. Now we did this approach because we were trying to make it as hands-off as possible, that we didn't have to program choices site by site. But this baselining is by far our weakest point right now in the algorithm. So I think we need to do more than, and I think Carsen has actually done quite a bit since this data was collected. But what I do think has been working pretty well is we're not triggering on these super short duration. I was worried we might see some events like somebody running their barbecue grill, but reasonably short events are being filtered out pretty effectively right now. One of the ways that we're measuring how well we're working, how well is this working, is by comparing the conditions we ended up with where our system was on versus off. So I'll do this one real quick, Carsen, because I'm pretty sure I put this chart together. Well, Carsen made the chart and I made the slide. So that green vertical line is the Fort Collins-ish average annual values, depending on where you are in town. Now, it's a pretty clean community, so some of these things get a little more challenging because of how clean we are. As it ran in this case, we only missed around 5% of the time that we would have said we were above kind of our typical ranges, where we didn't run. So we did pretty good not running or not missing events, but we're certainly in a pretty protective mode, where there was around 70% of the time that it wasn't actually that high above our average, but the system ran. This has to do with that moving baseline. This was during a period of time where we had some unusually low air pollution in Fort Collins, which means our baseline was extremely low, and even minor events put us out of our control window. So some of this again goes back to our philosophical approach we want to take. Yeah, we could have done protection by running this system, right? There were elevated levels compared to what had been there before, but this system would have been running a really large fraction of the time across the year in this case. Again, particularly clean. I think we're supposed to have worse air pollution the next couple days, so we'll rerun some of these. What we're going to do is, as we hone in on our location, we can run all of Carsen's algorithms on historical data and see what we would have gotten. This data was active from his control system outside running, so all of the bits and pieces running. Okay. We're gonna start talking about how we deal with problems.
Yes, yeah, so air handling. So the central hub, if one of the nodes does not send data within the last 10 minutes, it will send a signal and it will reboot itself, which will would hopefully alleviate any problems that node was having, which a lot of times resetting something does work. So the other issue is these nodes, they have to be connected to the Wi-Fi for that reboot to happen though. So if it is not connected, there's not much else we can do except physically turning power off and on. But one thing we have added for the network connection, it will report the connection status. So how strong the Wi-Fi signal is, which I've tested many times in my house and it works. I can get it down to like 10% strength and it will still send data to the central hub. So and then there's also the nodes will send error messages over the MQTT if various issues arise, such as sensors. A lot of times will start throwing various errors. So it'll send those messages to the central hub, which we can then fix after finding out what the issue was. I think a big focus right now is improving our air handling. So I'm currently working on adding various other things such as similar to the reboot, yeah, I think that is the main focus on improvements for this system right now. Yeah, so we not too long ago ran a test inside of a home, Dr. Larange's home. 2 weeks, which on this graph you can see was fairly consistent. There was a gap, which we don't for sure know the cause there. We can only make assumptions because we didn't have as much air handling as we do now. But this, yeah, so we assumed probably the network dropped out. Maybe it's hard to tell. There's other issues with the Sensirion sensors. Sometimes they will throw errors and stop collecting data, but I've added other stuff to reset those every day so that system, and then the reboot would occur in this situation. And yeah, so the second iteration involves all the air handling, and then it is now on using database instead of logging to JSON file, which was another assumption made that was made for the issue, just because the JSON file might have filled up too much and the Raspberry Pi could not send any more data to that. But yeah, we, like Dr. Larange said, I gave him the second iteration of the system, which will undergo a test soon.
So to that data issue, we're collecting a lot of data from these hubs right now, so pushing it pretty hard. And I'm super guilty of what I'm about to say. We have a tendency to want to collect all the data we can get, which I'm fine for us to go down that route. I think we should think about, because of the duration of these studies and our uncertainty about how often we'll be able to go collect the data and if homes will have internet, what is the actual frequency of what we want to be logging. Again, we can log all out, collect everything, but we have a lot of sensors, especially if we start adding more than one emissions node inside or outside, which we can do. Making sure that we're collecting data that we anticipate actually doing something with, as opposed to just collecting data for the sake of collecting data. Okay.
All right, yes, dashboard and interface piece. This dashboard on the right, you can see, is what I'm currently using for just testing purposes, which it shows each node and its individual data, so PM 2.5, humidity, temperature, and Wi-Fi strength. I was able to reboot each node individually with buttons on this dashboard. Yeah, but this is just purely for testing purposes and not necessarily would be used in the home. Yes.
If you remember back a few months, the other dashboard we have, which we anticipate being more the user focused, is how we're presenting data back and forth. And I was slow in doing this, but I got it out before the meeting to Erica and her team to have a interactive version that they can start playing with. That's purely kind of proof of concept. We're 100% open to how people want to graphically show things on the dashboard. Where we've been focusing most on the user-facing dashboard is proof of concept, making sure that we can display things in lots of different ways, making sure that we can capture things. What is good is there's, I think, very little that we can't log in terms of how people are interfacing with the dashboards. Button clicks, screen time, last time since somebody woke it up from a kind of a black screen, sleep mode, screensaver type piece. So the good news is I think we can capture essentially everything that people have talked about in terms of physically interacting with the dashboard. We just now need to decide what we want to actually show to people. But I imagine there'll be a working session between us and the human interface folks here pretty soon.
Yes, so future improvements to the system, once again, just enhancing error handling, and then obviously dashboard updates. I think that's the least developed thing in terms of ready for the household, because we don't really have one too developed for the user, and then also developing the anticipatory algorithm for poor air quality events. So
So we have some buttoning up to do, to be sure. Good news is we're at functional for everything. Certainly places that we want to start refining, but one of the goals, and this is where it merges with Jordan's work, is we're just going to start putting these out and letting them run for as much time as possible without us interfering with them to see which gremlins still exist in the system. Right. What questions can we answer? I didn't go. Okay. No question in the chat. Questions for either Carsen or I?
I have a question about, well, I don't have a question or an answer, but you asked a question about how much of the data we want to collect. And I'd like to know more about the trade-offs, or how many channels and for how long could you collect that kind of thing without a pickup? Because I feel like we are looking at patterns, and so it's possible to identify only certain times when we need to record, but I also feel like we are still in the discovery phase of understanding how things work. And so I'm also hesitant to give up something that might help us in discovery. And again, that's probably just a greedy data person's approach to it.
Yeah, a couple pieces to put in there. We're not talking astronomical amounts of data here. Right? This is not something that we're worried about not being able to put a large enough data storage, memory storage on it. That's fine, right? We're not talking huge files. So we can choose to like throw everything at it and slog through the data. That's, you know, certainly possible. I think where the trade-off is, and this is one that we need to do more testing on, and getting different people with different devices, I think would be a help here, is how long would we have to sit at the house to pull that data off if we're doing this, get on the network and pull the data, like be in close proximity and pull the data. We need to do more looking there. We're not talking sit there for an hour, but it will take some time to move these things, especially if they're big data files. The other one I would say is I think there's an opportunity, and I haven't asked Carsen to do this yet, but it's been on the radar here, that we have the full data file and we have the data file that we anticipate our field teams pulling to check for functionality. So we could have a much lower resolution, and I'm talking like minutes resolution of data as opposed to 10-second data or something that Carsen is logging right now, that we pull while the units are in the home, and then have that full resolution for post hoc analysis once we go back to collect the data. I think that's a possibility too.
It seems like a not terrible compromise, but it sounds like a lot of work.
I don't think it's too bad. I don't see Carsen grimacing yet about me making that suggestion, so that's a good sign. I think my bigger point in terms of thinking about what sort of data we want is the other trade-off there is when we get to the analysis phase, we're going to want to do analysis pretty quickly, and collecting tons of data that just muddies the water as opposed to collecting the data that we really care about.
Yeah, it's surprise, surprise, this is you, Danny. I mean, you guys are gonna be doing some analysis too, I'm sure, Christian and Carson,
Yeah.
but this is where I see Danny's role, and Danny's gonna be relatively new. He's gonna have a little bit of a learning curve probably. Although he's already got a fair data background.
I just see study after study where they so over collect data that actually getting to their core questions becomes more difficult than if they had just collected what was useful for them.
Yeah, like we
It's just a
haven't even-
post-processing thing, right? It's just a time thing.
I know,
but-
we haven't even looked at the particulate matter data from the Epic homes, for example.
Yeah.
So I hear ya. I hear ya.
Now, I do think it's one of the places why we want to start having these units just sitting there running in lots of places before we go out, is we can start sharing data files, even if they're boring, because it's, 5 units all sitting on the powerhouse roof, so that people know what the data looks like, so you can start building your data pipelines from day one.
Are we planning to have weather stations at these homes?
I've not heard of anyone bring up weather stations before.
Yeah, so we may want to think about that. Because I think, Dom, what you're seeing is that the homes kind of look like each other and they look like Powerhouse. Correct me if I'm wrong, but they really don't look like the airport.
Yeah, because we compared them to Powerhouse, the station that they have out at Ardec, I think. But the atmospheric science department. And then we did an airport as well. And yeah, there were certainly some trends where the houses looked more similar to what we were seeing at Powerhouse, and then the airport and the atmospheric science building all kind of matched up. So yeah, there definitely was some differences when we were looking at the weather data.
And the temperatures are not very different. It's really the wind speed. So we don't have to solve that now. My guess is that Christian, you guys certainly would not have to collect wind speed, but we probably want to have a hub somewhere, maybe at our partner's location. But
I think
that's
it
not a
makes sense.
condition for you.
Yeah. The other one on our roadmap, and this might be most relevant to you, Danny, the plan is to finish the pipelines so that as this data comes back in, we push it to our central server that we already have, so it's already merged into the central database as opposed to circulating data, house-specific data files. So we already have a kind of data merging plan there, so hopefully that will ease some of the data analysis for other folks as well.
Yeah, and we have merging raw streams already for the Epic homes too. So I don't anticipate that being the issue. I think the issue is going to be more like we have never dealt with user streams and tried to relate those. That's just not been part of the past.
So in terms of next steps, I think what we'll be doing is Carson will keep you working on the error handling, and we're just going to start putting more and more of these units out and letting them run. And then especially for the more participant focused folks, putting hardware in your hand to try and figure out what doesn't make sense and what sort of graphical interfaces you want. The other one we didn't talk about here, and I think will be part of Jordan's conversation when we talk about his hardware and the actual control pieces, is what happens when things fail. And the short answer is everything's getting set up to fail to off. So if we're not getting signals for, and we have to figure out what this time delay is going to be, what we want to set it as, but if we don't see data from the central hub for long enough, the control node just shuts everything off. It is the most conservative, safe approach.
And
the
Christian,
oth-
is the issue of baseline, it seems to affect the outcomes, and it also seems to shift with different regimes. So that's
Yeah.
probably to maybe just flesh out as a group too.
Yep, I think the first one, maybe Carson, you've already done this, I can't remember if we've finished that conversation yet or not, is I think it's useful to have this moving baseline, but I also think we need a minimum baseline, especially if we're dealing in some
Mhm.
spaces that are pretty clean. Who cares that the baseline is moving, but it's never going to drop below, what we predetermined for that geographical location. That'd be a more hard-coded piece where the varying over time would only raise the baseline,
Yeah,
not drop it from our minimum.
or the threshold above that baseline could be changed. I know we've changed that based on so right now it changes threshold based on how high the baseline is, and we could refine that number to change.
Yeah, we hit the perfectly bad situation when we were testing this last time because it was like 3 micrograms average for most of the time that his last batch was running, which was the train going by, which is actually I think what a couple of those peaks was enough to push us outside of what we were viewing as typical for those days. So right.
Christian, I do have a question related to that. You were talking about length of the event.
Mhm.
You like to decide if it's a blip or it's not a blip. Do you typically decide on a blip, non-blip, cutoff based on looking at a lot of data to see what's typical and atypical? Or do you have in your field a time period that you say, or maybe it's determined from a health standpoint?
Yeah, I think I'd love to hear from some others because I do think other people on the call have probably looked at these in some different ways. How do we have it in there, Carson, right now? It's just like a number of sequential points above.
Yeah, yeah, I think it's a number above, and it's like, and I think if the baseline is below a certain number, I think like 10 or maybe it's a different threshold, so maybe like 1.5 times baseline. I think it's 20 points above, which would be 20 minutes. So I think that's currently what it is.
But certainly one that we can play with how fast we're pulling data. We don't have the concerns that we do in some other spaces that there's like an autocorrelation concern, like we can treat each of these in independent measurements, which is nice, simplifies some things. If we push the sensor as fast as we could, we would hit that issue, but we're not logging nearly as quickly as the sensor could be doing it. I think that 20 minutes is pretty arbitrary right now. I know for ones that I've seen before, like in that indoor air quality space, is would it be large enough to move your new average above the standard deviation of what your baseline was? Right, so you wait long enough that if you viewed the time before with or without that, would you actually have it be a statistically different point? The challenge there can be is if we have really noisy but low areas, the statistics get maybe screw us up a little bit. Some of the thresholding plans we've thought about before, and I've kind of backed off on this because I thought it was a little too aggressive, is not look at the absolute change, but do it more categorical, that we're moving from the one AQI tier to the next AQI tier, but the log spread of that could get challenging in bad air quality events, right? If we're in a dirty area, it's a pretty big step to go to another AQI. level, and that's really too coarse of a jump. So where I think we're at right now is, I think we have good algorithms that we can do to be repetitive. We need to make some. What approach do we want to do as a study based on how we want this thing to run? Which I think is really going to be dictated much more strongly than I thought early on in the project by where we go to and how many events do we want to capture. We can tune our algorithm to say, we're going to have this thing turn on average 3 times a day. And that might be a useful and valid choice for the participant survey side of the data we want to collect, even if it's not the operational one that we would do from a real health standpoint. And we've done most of it so far based on trying to protect health, like keeping the house clean. But that means we don't necessarily run in a cadence that's going to be useful for the other aspects of our study. That was not one that we... Getting enough events in our fairly short deployments, I think, is actually going to drive this algorithm choices much more strongly than I was originally anticipating. And Tammy, I've not forgotten about getting you your data for those sites. That is, I pulled most of that this morning.
Okay, thanks. Yeah, and I think you say that's really important, but that's another thing to talk through because it affects what we do in the field study, but it also affects how the thing might run in the first place. Right, and if it is that dependent on location, what do we need to know about a place? Maybe I'm asking too many questions that are too far out. And it'll become more obvious as we get experience.
Yeah, I think one way to tackle that is now that we've narrowed down potentially some of the sites, you know, Carson started this algorithm development purely from historical data. So we can go back to those reprocessing of historical data now that we've constrained the number of cities from infinity down to some places, and we can start looking for how would this algorithm, how would the different algorithms run in Fort Collins versus, I'm blanking on all the other cities.
Yeah, that's fair.
Alamos.
Don't take my mini list as too
You're right.
committal either, because there may be another 1 or 2 added, but you're right, it is now more constrained than
And
it
I
was
think, to be
before.
honest, testing these algorithms at some of those sites may help us say that site is, although a good community for needing our help, is a really bad one from our validation study.
Well, that's a really interesting difference. I hadn't thought of that.
You know, choose a city that they have, you know, 10 bad events a month, but they're only going to be at a given operational point on our matrix for 3 weeks. I can't remember the dates and the times. That might make it a poor choice for validating the technology.
That's fair. Well, I can pretty much guarantee that whatever site we choose, they will have fewer events than they were going to have without us being there. That's just how it works. While I'm thinking of it, Will, Kristen asked for access to your file. This is Kristen. You may have seen a strange name coming up. So could you please allow her to see the candidate site file? Anyone else today? Thank you, Christian and Carson. It's
Yeah.
really hopeful to hear the words like "it works." That's pretty awesome. Yay!
We haven't seen smoking circuit boards in hours.
Wait, we could test with you as the source.
Yeah. We could put one down in the laser lab based on their alarms yesterday. All right, for anyone who has interest, we have a lot of these pieces documented on kind of the team Miro board, as well as just kind of the digital white space that we keep a lot of this stuff in place. So if anyone needs access who hasn't seen it already, happy to do so.
Okay, thank you, everyone. Have a great weekend.
Thank you guys.
Thank you.
And